Today we're going to continue talking about quadratics, and we're going to talk about taking big puzzles and making smaller puzzles out of them. So tell me what you notice about this picture, and if this was a puzzle that you could print out, how would you rearrange the pieces? And what is the total area of this puzzle, not including the white spaces? So pause the video and write down some answers to these questions. So you add all the squares together, you'll get this giant, expression. You might have a different order, but it's same idea. Just add all of them together, and then if you simplify it, combine the like terms, you get 4x squared minus 16x plus 8x minus 8. If you combine those middle two terms, you get 4x squared minus 8x minus 32. So that's the area of the whole puzzle. And if we want to sort by color, maybe you'll notice that there was 4 blue, 4 green, 4 yellow, and 4 gray, and they're all the same area. So if you sorted them by color, you might have gotten a little simpler, and you would have ended up with the same answer. Another way to approach this problem is by actually coming in and rearranging it. And you'll find out that it makes this nice rectangle. And there's actually 4 smaller puzzles inside of this big rectangle. And the area of each small puzzle is x squared minus 4x plus 2x minus 8, which implies to x squared minus 2x minus 8. So the total area is 4 times the area of these small rectangles, so 4 times x squared minus 2x minus 8. And using the distributive property, we can see that we multiply the 4 out. If we multiply the 4 on each term, then we will get the same answer that we got in the last. So let's focus on one of these small puzzles. Let's factor it. So the dimensions of the blue box are going to be x and x, and the dimensions of the yellow box, we're going to guess, are going to be -4 and 2. And we'll find that it is -4 and 2. Because I noticed that the yellow box and the gray box both have a -4 as factors, and the green box and the yellow box both have 2 as a factor. So the area of the small puzzle is going to be x minus 4 times x plus 2. So let's and we'll notice that there are 4 of these small puzzles. So if each small puzzle has an area of x minus 4 times x plus 2, then our total area must be 4 times that. And using the distributive property to multiply out gives us 4 times x squared minus 8x minus 32. So this new form is much more informative. It gives the height, which is x plus 2, and gives the width of the small puzzle, x minus 4, and tells us how many small puzzles make up the big rectangle, which is 4 small puzzles. So you might be wondering, how can we know when a jumbled mess it has hidden small puzzles in it? So how can we know when we can rearrange this? And a similar question might be, how can we go from distributing the 4, so taking this 4 out and distributing it, how can we go the other way and undistribute the 4? Well, we notice that each coefficient, so that's these numbers in front of the x's for -8 and -32, is a multiple of 4. So we can take out the 4 from each term. So we could just divide each term by 4, and that will give us x squared minus 2x minus 8. And then when we divide the 4 out, when we undistribute the 4, we must multiply it across the whole thing. Which, if you look at this looks like a distributive property question, and if you distribute it out, you get what we originally had. So notice that this is the same form that we had when we organized the puzzle into 4 small puzzles. So each small puzzle was x squared minus 2x minus 8, and when we distributed it, we got when we noticed that there was 4 of them, so we multiplied by 4 at the end. So what if we had a giant element? We want to undistribute this giant mess. Um, we are going to undistribute. We're going to organize this giant mess. We have to undistribute. And so undistributing is usually called factoring out. And we want to find the greatest common factor of each term and then factor it out. Doing this makes organizing into the big jump of mess into small puzzles. It makes it easier. And we don't have to actually put each thing, build the whole puzzle. We just have to build one small puzzle and we'll figure out the entire puzzle. So this picture here has 25x squared, so 25 blue boxes, 10, or not 10, 100 x's. So of these green boxes are x, have the area of x, so there's 100 of them, and there's 75 unit blocks. So we could write this as 25 squared plus 100x plus 75. So let's make sure we save that. So this is just an inventory of what kind of people we have. So let's factor our 25x squared plus 100x plus 75. How many small puzzles can we have? Well, each coefficient can be divided by 25. If you live in America, you know that you're familiar with how quarters work. It's pretty common globally, in quarter dollars. So, 25, 50, 75, 100. So 25 divided by 25 is 1, 100 divided by 25 is 4, and 75 divided by 25 is 3. This means that each small puzzle is made of 1x squared, 4 x's, and 3 unit blocks. So 1 blue box, 4 green boxes, and 3 yellow boxes. So we're going to distribute that, or undistribute. So with one thing, what we can do now is we can factor and get a more complete picture. So you'll see here that I combined the smaller boxes. So we have a 1x squared box. We have our 4x boxes. There's actually 4 of them inside there. And then there's 3 unit blocks. So there's 3 unit blocks inside of that. And so what we can do here is we can make our puzzle. And I'll just change the color so that we can tell the difference. And so there we have our puzzle, and we need to figure out what values of what side lengths to choose. We know that the dimensions of the blue box will be x and x, so we need to choose the dimensions for the yellow box. We're going to guess 3 and 1, because 3 times 1 would give us an area of 3. So we get 3x, we would get 3x for the green box, and we would get 1x for the gray box. And 3x plus 1x equals 4x. And 4x, it was the area of that box that we split up, so that's exactly what we need. 4x is the middle term in our quadratic. So we need to make sure that our areas add up to the middle term. The middle term of our quadratic. And so we see here, we can figure out the area. And the area is x plus 3 times x plus 1. So that changes our thing. We have 25 times x plus 3 times x plus 1. So going back to our jumbled mess, this means that it can be sorted into 25 small puzzles that have dimensions of x plus 3 and x plus 1. So 25 of those puzzles that we saw in the last slide. And using algebra, we completed the puzzle. We didn't even have to print it out or anything. We know what the whole puzzle looks like, and we didn't even have to we only had to count how many of each piece there were, and we didn't actually have to do any jigsawing or anything like that. We used algebra to do the puzzle, to complete the puzzle. We know what the puzzle looks like. We made 25 small puzzles with dimensions of x plus 3 and x plus 1. So here are some follow-up questions to think about. What if we wanted to factor out a number that didn't divide each coefficient nicely? For example, we wanted to factor a 3 out of 3x squared plus 2x plus 4. What would that look like? And knowing that x squared is actually x times x, and x divided by x equals 1, what could we factor out of 2x squared plus 4x? And the hint I'm going to give you is the answer is not just 2.